start.
Are you recording?
Yeah.
Well, welcome to the Downey Planetary Museum. We've got the 3 stations cordoned off into sections. So just make sure you stay with our group, our 6 exhibits that we're going to show you today. So I'm going to divide you up into 2 groups, and I'm going to take you over to the Mechanic Pendulum. Okay, so this is the Mechanic Pendulum. Can you tell me what a pendulum is?
Is it like a clock?
Yeah, it's like one of those old grandfather clocks that an arm that's moved back and forth. That's a pendulum. It's an example of periodic motion. It's very predictable. Means you know what's going to happen next, right? So it's always going to go back and forth. But in this case, you got this pendulum. Louder? Sorry. So in this case, you got this pendulum, but instead of just being one pendulum, it's got 3 smaller pendulums attached to it. So when you start it spinning, instead of going in a predictable way back and forth, the smaller pendulums are going to influence the motion and disrupt the overall system. So if you start it going, it starts to behave predictably. A normal pendulum will just go back and forth in a very smooth way, but this is, it's jerky and it's wobbly. Sometimes it goes higher, sometimes it goes lower, and you can never predict what's going to do next. And it's a model for complex systems like weather, where small changes to the overall system can have unpredictable effects on the whole, like small changes in weather or in temperature, air direction, wind pressure can have a drastic effect on the overall weather. The next exhibit is the lightning globe, the one that I know you all really want to see. So before you guys touch this, I need to know what the 3 states of matter are. Yeah, I would be. Okay. Yeah, liquid's one.
Gas.
Gas is another.
Solid.
And solid, correct. So you got solid, liquid, gas. There's actually a 4th state of matter called plasma. And inside this orb, you're seeing gas and plasma. Plasma is gas that's been heated so hot that it starts to glow. So there's an electrode in the middle of this orb that's very negatively charged, and so the charge needs to escape to the outside, so it has to go through the gas. So it turns the gas into a plasma and travels through it, and that's what these blue tendrils are seeing. That's the plasma carrying electricity to the outside, and that's what real lightning is. Real lightning is a charge that accumulates in the clouds, and it returns to Earth by turning the air into plasma. That's the brilliant white flash of lightning. So another cool thing about the orb that's fun is that the electromagnetic field in your hand can draw the electricity toward you. And then I let the kids touch it for a while. And then the next step is sending over to the rocks.
Alright, so what we're going to do is we're going to take a vote. Which one do you think is the coolest rock?
I like that one, shiny.
Alright, we're going to listen to that one.
The metallic luster and brassy yellow hue of pyrite can often lead people to mistake it for gold, earning it the nickname fool's gold. It's actually a common iron sulfide. The name pyrite is derived from the Greek word for fire, no doubt due to the sparks that result when pyrite is struck on steel or flint. This property made pyrite popular for use in early firearms. This pyrite specimen comes from Peru.
Alright, so do you have any questions? Alright, so now what we're going to do now is we're going to move over to this meteorite. This particular meteorite is from Namica-land in Namibia, Africa. It was originally about 4 meters by 4 meters by 1.5. Can you tell me how big about 4 meters is? Alright, so you see this gentleman over here?
Yes.
4 meters is about twice his height.
No way.
Yeah, so 4 meters up, 4 meters to the side.
Wow.
It's a pretty big one. This one is one of the smaller pieces. It actually landed in 1838 and it actually broke up over the Earth's atmosphere. I believe you are going to learn about friction in a little bit. You'll learn about how it affects substances such as this. In this particular instance, when it entered the Earth's atmosphere, the friction caused it to break apart. So before it hit the Earth, it actually exploded. This is one of the smaller fragments that hit the desert in Namibia. One of the bigger fragments is actually 1,100 pounds. Now, if you feel this meteorite, you can actually feel the pockmarks from where the friction in the Earth's atmosphere actually burned away some of the iron. Now, do you have any questions? Alright, so now we're going to move over to the friction demonstration.
So this exhibit is called the TV Twister. This is an old style cathode ray tube television. This is an old style cathode ray tube television. They're not very popular anymore, but you might still have one in your home. The way this works is there's a gun at the back that fires a stream of negatively charged particles at the screen, and a little magnet inside directs the beam left and right, back and forth across the screen so fast that it paints the whole image 30 times per second, faster than your eye can see. Now, because the beam is negatively charged, you can use a magnet to deflect the beam and distort the picture.
Wow.
Our last exhibit, after I got the magnet, this is the Euler's disc. It's an example of how energy and potential energy and friction work. Once I put energy into this disc to start it, once I put energy into this disc to start it spinning, that energy will stay as kinetic energy in that disc unless something acts on it to stop it from spinning. And that force that acts on it is called friction. And it's going to go over the edge. Fantastic. It's the camera. I blame the camera.
No worries.
So what's going to happen here is that there's a tiny amount of friction between the rim of this disc and the cable. Can anyone tell me what friction is?
No.
Friction is the force between two rough surfaces that makes it harder to rub them together. And it will eventually stop this disc from spinning, because there's so little friction, as you can see, it will actually spin for a very long time. That is most of the end. It's going to fall off. I'll be embarrassed on camera.
No worries. No worries. So this is for volunteers. They get it.
Oh, okay.
Yeah, so it's not for kids. No worries.
And that's everything.
And so now you just ask questions and review with them. Make sure they got all the concepts and then let them play with
Yeah, we
the
do the
things.
passports, make sure they pick out their favorite one, write down something they learned, we stamp them off, and then we let them go do their thing.
Got it. Thank you.
Did we do okay?
Huh? Oh yeah. Oh, you did. No.